with a little bit about myself. So since I'm joining Royal Cyber as the global data analytics head, this is my first interaction with most of you. So I've been working in the industry for about 20 years, 20 years this year. And I started as a software engineer, did my PhD from Michigan State as a Fulbright scholar, then worked in the government sector as a researcher developing solutions for our submarines and ships and anti-submarine aircraft. The solutions are still up and running. I'm quite proud of them. But then I segued into the corporate sector and joined Teradata. In my previous role, I was leading the data science, artificial intelligence, and the business intelligence teams there, based out of the Teradata GDC, working with clients across the globe, the Americas, Asia Pacific and Japan, Europe and North Africa as well. Clients like HSBC, American Express, Etisalat, Telenor. It's a wide domain. My focus has been on finances and financial sector and telecom, but I've worked with clients in the healthcare, retail, government sector as well. Primarily focused on developing and deploying ML and DS-based solutions. So that's my primary concentration, but I've had experience working with the data foundation side of it. And as I'll talk about it as we move forward, data foundation and data engineering is the major underpinning of actually developing the cool analytic solutions that you hear about these days. More important than the analytics themselves, a lot of time it's getting the right data in place and structuring it and making it available in a form where you can drive business value out of it. So first, to begin with, what are we working on right now? A lot of you might be familiar with this. We have expertise across a plethora of technology stacks: AWS, Azure, Kubeflow, Databricks. There's a great focus on MLflow right now. And we are partners with a lot of those organizations, including Google Cloud, Snowflake, AWS, and Databricks, so that we can drive engagements or projects where we are delivering world-class data engineering and data science solutions in multiple models. We familiarize our clients with the partner cloud platforms and the key capabilities that are present in those platforms, along with the best practices on how to utilize them. We're working on expanding our data engineering capabilities in terms of the Lakehouse architecture, how we could structure a full-scale Lakehouse, how to expand it, how to make data available on top of it through enterprise-scale data engineering. And then the next step after that, artificial intelligence and machine learning-based solutions, how we expand beyond basic reporting and analytics to value-added solutions, which can give you new ideas, generate new thoughts, and drive insights where no insights were possible before. And these examples would be the same. And then how to operationalize those, the focus, expanding focus on these talks, in this talk, using things like MLOps. As I'll discuss subsequently, this is a critical component. How we operationalize AI and ML models is the need of the hour these days, because POCs are well and good, but how to make them available in a production environment, that is the challenge right now. So there's an evolving focus, like I said, on improving the data engineering aspects of the overall analytics ecosystem. We partnered with Databricks, and we're looking at how we can structure this as a standard process to ensure continuous ingestion of data through a medallion-based processing architecture, where the raw data is cleansed, structured, and made available for downstream consumption for generating business insights. The downstream consumption includes the ML and AI solutions that I'm talking about right now. But not just this. The data, making the data available and then making it available, ensuring that it's consumed by the ML and the AI solutions is not enough. What is the problem? 65% of predictive models are never implemented in production. It takes on an average 5 months to validate, deploy, and scale new analytic models, where 25% of the data scientist's time or data engineer's time is lost interacting with DevOps teams. Now that's wasteful, right? You have an interesting POC, you have an interesting solution, where you quickly show it to the client. Oh wow, something like ChatGPT, it's completely summarizing your information and making it available to you for consumption. But how do you do it at an enterprise scale? It's nice to see those viral bites that quickly propagate across the global social media, but how are you really generating value out of those in the form of an enterprise level solution? That's the challenge. And that's where the need for model ops and ML ops comes in. These are customer facts. This is based on a survey of major financial services clients and analysts who are looking at the domain itself. As you can see, there's a gap in the perception right there. The customer says that they have an average of 270 number of models in production at a given time. 19% of their business units use artificial intelligence regularly, but they do it across 5 or 7 different tools, and only 25% of effective they worked on are actually going to production. So as you can see, at each level, there is significant wastage in productivity, in productivity, because the models that they are generating, even the ones that they're working on, they're not putting them into production. Why is that? What is the problem? So the problem is that there is a significant gap between exploration and production. Production model monitoring is non-existent or minimal. You need a framework to be able to do this in an automated manner. CI/CD pipelines for ML models development, deployment, monitoring. These models don't, you can just throw them into production and they'll always work. Data changes, data profiles change, features drift, model performance drift as the data profile changes. You need to have a mechanism to ensure that those challenges are handled in a manner that the governance becomes simple. Model governance is really important. It's usually a boring topic, so more people don't look at it, but you need a framework in place to be able to do this well. Then the production manual model lifecycle itself, there are a lot of manual steps that are involved. If you don't have an automation framework, you have to continuously, if you know that there is a need, you will need to have to retrain the model. And the engagements I've worked on, in most cases, we've had to develop bespoke model factories based on that specific technology stack. That's workable, but it's bespoke for every engagement, and it takes a lot more time, and it takes a lot more expense in terms of the customer and for us as well to ensure that it works fine all the time. So there needs to be a way to handle this well. So how do we do that? Operationalizing AI and what are the main challenges and what is the process that you follow is going to be the primary focus of this talk today. I'll try, like I said, I'll try to focus this or position this or structure this in terms of a business problem. How, in terms of a retail vision analytics solution, would you set up an entire architecture and workflow where the results are underpinned by a strong technology stack, which is automated through a model ops lifecycle? So let's begin with a quick look at some of these. So AI is creating value today, right? Over the last decade, over the last 15 years actually, AI has experienced something of a renaissance with processing architectures now available. It's been poised and it has been disrupting industries as we enter the next 2 decades. It's already providing early adopters questions. How do we get into this? How do we structure this in a way that the solutions work well? So the breakthroughs in AI have centered on 2 essential parts. These 2 parts, when combined, allow us to make increasingly accurate predictions, leading to better answers, right? More learning algorithm, all of this leads to better answers. That's the objective. The first part is more data, where we're seeking more perspective through additional features and dimensions of data that describe all aspects of a client's business. We talk about talk a little bit more about this in detail. So I'm sorry, I didn't see my laptop with this. So this is the objective, right? More data, more learning, like I said, are driven by both these aspects. I've talked a little bit about more data. What do we mean by more learning algorithms, right? These are driven primarily by open source innovations. The learning frameworks that are available now on the market have removed some of the cost barriers that have been placed for a long while. And I'm sorry, yeah. And when applied correctly, these models are can be a game changer. They can be the differentiator in ensuring that your business is generating such value that it's a first mover. It's going into a domain where nobody has been before. But you need to architect these solutions really well, and that's where the overall technology stack and the infrastructure comes into play. Why, with all of this, the reality is that in the enterprise, most of these is how do we design an architecture that provides compute architectures across the cloud and within at the edge and within centers that can solve both real time and batch scenarios. How do we get access to GPUs as and when required to accelerate the training of our models? And how do we apply this inference at scale? When you're talking about thousands of video streams coming at the same time into a central location, how are you able to provide real-time inference on top of those video streams? What are the architectural gaps that you need to address? That's a major challenge. Then how do we blend traditional machine learning techniques with the deep learning neural networks that are available in the market? You have to understand deep learning is not the one size all solution that fits everything. It also needs to be provided context. There are additional traditional data sources which I'll talk about subsequently that can help improve and elevate the solution that you are providing through your deep learning models. So as a next step, we talk about the data that comes into play. Over the last 40 years, we've captured transactions from operational systems that's highly curated and that leads high value. Then, over the last 20 years, we've been focused on understanding the high velocity data of interactions from mobile devices, web and social media. There are things like where the interactions are human generated. When you're watching a movie on Netflix, for example, playing a video game, texting, or browsing. That's been the next stage of the data foundation. And then moving on from the previous decade and onwards to this one, we'll be looking at, and we are looking at observational data. How it will be shaped by our ability to extract extra values from previously intractable data sets, things from derived from things like IoT sensors, audio and video streams. These observations are machine generated for the most part, and they are proliferating. They are available in the enterprise today. So it's the ability to observe the behavior of not just humans, not just individuals. It's the ability to observe the behavior of machines as well. That's part of the data sets that are continuously being made available right now. So you move. So as a next step, we look at an example of some of those data. The audio video streams that are coming from your security cameras, the ones that you see here, for security coverage and safety, audio coming in from the microphones on your phones, then sensor data coming in from different production processes. All of this needs to be made available, staged, and in a manner where it can be it be available to solve a particular customer problem, and in a manner that's completely scalable in a production environment. So my objective here would be to show you, we'll talk about a problem in a retail context, right? But this is generalizable across various domains. The problem here is how can we ensure customer satisfaction and reducing the cost to serve. Here we are focusing on a couple of videos in a retail store as well as a retail banking branch setting. And I'll walk you through how we apply different learning algorithms and what's fundamentally different about the state-of-the-art techniques that we use based on industry best practices that over data that can be live streamed on the cloud or can be made available in a batch processing mode, just to build an understanding of what individuals are doing across time and space. So if you look here, you see four or five, six different people going. The people on the left that you see are engaging in exhibiting a walking activity. There's a path developed, and then they stop and look at a particular product SKU. That's an engage activity, as you can see from the changing color of their callouts. On the right, right, you can see an associate engaging, showcasing particular attributes of a product. Again, there are subtle contexts in play. This is an overhead camera, PTZ camera, and you have to factor in the movement of the camera while it's absorbing those images. The factors that you don't normally look at, but if for a solution, this is something you need to factor in so that the detections remain at an acceptable level of accuracy to give the results that you want. And the next one would be a retail bank setting. As you can see, the customer number moving towards the teller there behind the bar, and basically asking the questions. On the left, you see an associate and a customer in an engaged activity. A couple of people are queuing on the right. So all of these are different activities that you're tagging based on their from the video, as you'll see right now, the guy got a lot of money, so obviously he's very happy, and he will now exhibit that happiness, and the model will automatically detect that, right? This is really obvious, but generally you would look at more subtle cues. That's part of the things that you want to absorb. What is the information that you're getting from that behavior? But see, what's interesting is that this is not the only thing that's important. Before we get into the details of how we do this, how we abstract that information and give that context, we need to talk about the framework in which this is made available, right? We need to talk about privacy, ethics, and compliance. Now, this is really, really important, especially in places like Pakistan and a lot of countries like Egypt, or even in the Far East, in fact. This is not something that we consider, but as a global organization, Royal Cyber would need to consider this when you're developing solutions in this domain. With the GDPR regulations in place in Europe over the past couple of years, this has become critical. I know things like what I just showed you a version of this. I worked on developing a solution for a Japanese bank where they asked us to track their workers. How much time were they spending at their work desk? How much time they were spending standing around and talking? How much time they were spending off the printer? How much time were they spending, around the water cooler talking? Right? This is not something you could do in Europe or Australia or US at all. You would be sued immediately. But in Japan, that's something the organizations want to do. I think in Pakistan also they would definitely want us to do things like this. But it gives you an idea. There are constraints in play that you need to consider. There are regulatory frameworks in play that you need to consider. Those should be the first step, the underpinning before you expand your solution. You need to understand the environment in which the solution can possibly be deployed, right? So let's take a look at the more learning algorithms processing pipeline that we can use to leverage the industry best practices and develop the solution itself. First, we need to baseline our understanding of the existing store performance. You saw a store example. This would include not just the observational data coming in from the videos, also things like inventory, payroll, individual attendances, operational reporting, right? We would need to calibrate our approach based on understanding the technical capabilities of the retail environment itself that can then be generalized across hundreds, even thousands of stores, right? These store environments can vary. We need to understand the context, how the customers are going to be moving in that environment. Then, as a next step, we talk about detecting the subjects themselves in the retail environment using multi-camera, multi-object fusion techniques. Different convolutional neural network architectures can be trained for subject detection. After that comes the subject path formation, what path they are following, right? What movement are they exhibiting? How do we do that? We detect the subject in every frame, assigning a temporary session ID, and then we can associate a session with an subject for the duration of the time that they are in the store. There are different types of tracking algorithms that you can implement, and you need to optimize those as well. It's fine. This was a relatively easy example. You're talking about a single store, but these solutions have been deployed and are being deployed at, say, locations like malls. There you have hundreds and thousands of people going around in the same way, tracking their paths, and then ensuring that one person is in front of the other, and then moves away. It's still being assigned to the same person or not? That's a common problem. People don't realize it. It's artificial intelligence, but it's still relatively now, right? It's evolving. Things like ChatGPT, what you see right now, that's the next step, but it's still as much data that you can give it to it and provide the right context, then it would appear smarter. You need to provide that differentiated context so that it can solve those tiny problems which are not something that you would consider on the face of it. Re-identification is a major problem in solutions like this. So that again is a challenge. The next step would be subject persona classification, talking about a little bit about who the person is and what sort of behavior they're exhibiting, the activities that they're doing, whether they're associates. I talked about associates, customers, clients, bankers. These are all individual personas. How do we classify those personas? There are certain physical characteristics that we can use, the activities that they're engaging in. All of this can be used to define those personas, which again provides richer context. More importantly, at the end, we can do activity detection after the persona classification and then run store experiments. Do things like A/B testing to determine which, so that those paths that result in conversions is part of the overall processing pipeline. But we see the most important part is not just this metadata. The idea is that how this metadata can be structured and provided context through all of the additional information that you have available in that environment as well. That's just movement or observational data. You know that the store is running sales. You know it has a certain inventory. What is its price history? What is its placement of the products and what overall displays, right? What's the schedule that people follow, right? All of this provides context. If there is a greater number of customers at a certain point in time, is it really driving sales or not? Because that means if it's not, if more footfall is not generating more sales, then what's wrong, right? Maybe the product placement is not right. Maybe the sales are not being in the right season. All of this provides you with context. This context can help you answer questions like, uh, how does customer engagement and queuing times impact overall sales, right? Then again, questions like how does marketing promotions influence conversion rates, and able to provide the better answers where this story started. Those better answers could be, maybe we need to move a product to a particular location so that clients are looking at it more. Maybe we need to increase staffing at peak timing so that there are greater conversions. There's not enough staffing to make sales to customers who are interested in particular products. All of this is really important. So what do we call this? We call this pervasive data intelligence, where answering on the video observations, but in a whole plethora of database solutions. See, if you optimize the solution itself, even SMBs should be staging their data at a central place. They want to be able to record their data, right? That's a minimum requirement. They need to understand their business data. That data should include some portion of what you have here. The observational part, that's becoming cheaper and cheaper. That's where our partners come in. You can now spin up GPU instances on AWS and Azure at a relatively low cost. The important part is on a particular hardware stack, which would allow you to run the inferences at a lower cost. You can stage the data in such a way that the overall cost, the training is the more costly part of the procedure. You can do that offline. Online, if you want to do real-time inference, you can deploy the optimized model, and it would still be really, really cost effective. That's why you get a lot of subscription-based services these days, both for video, audio, even text inference, right? So that's a major concern. But again, the context is key. You get services for deep learning based inferences. That's only part of the solution. The data, the SMBs would have that data. They need to know which data should be added to those observational inferences to generate the right value. Thank you. I think this was really helpful because Muiz pointed out the business considerations. You have to be part of the race. You have to keep up with what's happening around you. Technology is a supporting tool, but it's becoming really critical to the underlying to the bottom line itself. It can drive revenue, it can reduce costs, and you need to be part of that conversation. All of our at least the enterprise level customers, even SMB level customers. Solutions like these are subscription based in a lot of areas, right? And you can structure it in a way where the overall cost is bearable in terms of their overall sales. So it becomes useful, right? So again, the pervasive data intelligence, it's being used to solve a particular problem. And in this case, the main problem was customer satisfaction. How do we do that? Based on the output, what I just talked about, we can optimize the floor plan. We can reduce walkouts by serving customers in a timely manner and giving them what they want based on the interactions that we've observed. We can improve the store efficiency, and we can provide them with the best experience that they can get, a personalized experience. You can see from the video observations that, say, after a certain period of time, a customer is not being served. You can set timeouts, say for 2 minutes. If a customer has not been served and they just sit standing there, you give an alert to an associate to go talk to that customer and try to understand what they want to do. This would increase customers. This increased customers. So based on my experience, what we did for a couple of clients in the US, they had about more than 10,000 stores, and they wanted an estimation of the ROIs. What was the improvement? What were the conversions? And this was critical. Getting an associate to the customer within a specified time period was really important. In addition to the optimizing the floor plan, we found out that was critical as well. But people need that personal touch at times. Still we are seeing a lot of touchless retail. There's not in as much in-person interaction. We do a lot of online buying, but if somebody is going to the store, then they want that experience. That otherwise they can buy it online, right? If somebody's going to the store, that's important. So you have to again understand the context. For online buying, this is not important, but if you're talking about places where people are actually being present in person, then these contexts provide value. Hope that was helpful. All right, moving forward. I talked about customer satisfaction. Again, the cost of serve. This is just to make it specific, right? What we can do to improve this, or address this business problem. We can identify demand surges, promote digital offerings, improve staff productivity. Overall, now this was the business problem. It needs to be underpinned by a flexible, agile technology architecture, which natively integrates model ops as part of the solution. So this is an example analytics workflow of the problem that is under discussion right now. You can train the model and make the optimized models available for inference at the edge in containerized solutions. So you can have Docker spun up for additional video streams. As new video streams start coming in, you continuously spin up new Docker containers, for example. And then all of that process is automated by the analytics ops solution. The model ops solution knows which models are performing up to the expected level of accuracy. It's at the right. You can see that this staging of the models is being combined with relational data before being made available to the business dashboard. New data is continuously being made available, and the training is done offline, where video annotation and storage can also be automated as part of the overall process. In this overall, solutions like these, data labeling can be a really time-intensive job. You need to think about automating that as well, and you need to make sure that automation is an integral part of your solution. There are tools available, but then you need to go beyond that. Deep learning models trained to label data is an integral part of an overall deep learning solution, because that really reduces the cost to serve, which was the question asked, right? So it's a combined solution which needs to be flexible enough to take advantage of the latest hardware optimizations that are available. You need to, right now in the market, you get lots of frameworks, you get lots of libraries, but practically you have to see what sort of hardware frameworks are available for them to be deployed. If you're talking about the biggest CSPs, both of them definitely have NVIDIA NVIDIA and Intel architectures. The NVIDIA Metropolis stack has DeepStream integrated with it, the latest version of which provides optimized versions of the popular deep learning algorithms. This is really important when you're talking about edge-based production deployment, because the cost increases when you're talking about very large deep learning models. The processing time increases. You need to be able to map it onto a hardware architecture practically, so that the SLAs that most clients usually expect are met. So that's again a consideration when you're architecting a solution like this. All of this process needs to be parts of the design phase from the beginning. How are we going to make these models deployable in an ecosystem where they can be reused again and again? This is just a different version of the same picture that I showed you. That was an actual instantiation. That was one of the ways that we implemented at one of our clients. This is in general. How do we bring in observational data and then make sure that it's mapped onto the storage integration and the overall infrastructure, so that the deep learning, machine learning, and the data analytics processes can leverage it through the model ops solution for visualization and consumption at the user end. This process needs to be as transparent to the end user as possible. It should not be that they are waiting on the results because there is a delay in retraining a model or processing a model. That's the key part of the overall solution. They won't understand. They want, if you've shown them the beautiful thing at the end, the pot of gold at the end of the rainbow, they don't understand how you got that together. If you've shown them once, they expect that every time it will be available with as and when they require it. So the architecting them in a way that, say, for example, the videos can all be stored in a object store. The training acts on top of it, but then the resulting metadata should be staged on something like a relational database, so that it's quickly available for BI visualization using something like Tableau or ClickSense, right? Because that means it's quick. They need to run self-service reports. Self-service reports means data needs to be quickly made available. You can't really depend upon real-time inferencing in that case, right? So then video inferencing should be not on the fly. Video inferencing should continuously generate metadata, which should be staged on the relational database. And then that makes it easier also for machine learning models, because the machine learning models can then act on that metadata by joining it together with the transactional data that's available on an ecosystem like that to generate additional value. The context is key. Solution part comes there, because you are architecting it in such a way that the customer feels that if he has a new question, that new insight that he wants to derive, it's available at his or her fingertips. So overall, again, the messaging is that you need to structure AI or ML based solutions in a manner that it solves a customer problem, identify a pain point, identify the AI or ML based model which is addressing that pain point, but then architect it in such a way that it's reproducible, scalable, and automated, so that the business questions that they want to ask are made available as quickly as possible.